We're gonna leave the more detailed lessons about individual language features behind us, and also specific classes in the standard libraries. We're gonna start looking at the more abstract view on programs, the more how do you use the tools you've picked up so far. And today we're gonna start by using one tool I've completely neglected, using different files, which is pretty helpful. So from now on you will see several tabs on the top and more files on the right for our programs to keep things a bit more manageable. First I'm gonna create a class game, which is gonna have a method, run, and this method will just be an internal loop. Oh, let's see. That line. Something isn't quite right here. No matter. It will sort itself out. Running. So yeah, close it up. And let's get rid of stuff we don't need. Same in here. And now we can do game.var, new game, game.run. Okay, let's quickly test if the setup works. So yeah, not useful, but it's doing something. Cool. So let's make this a bit more useful. And first we're gonna set a limit to how often this loop runs, because I don't want to freak out my PC more than I need to. Let's say we make a time span. Does it not? Something is really wrong. You just open the file and you maybe didn't pick it up. Oh well, yeah, from seconds, mine. Why not? And we store that in another time span, and this is the frame length, let's call it that. So how long will each frame last? Well, we do it in 60 frames for now, 60 times per second, so 1/60th of a second is how long one frame will last. And then we're gonna use the stopwatch, something we haven't looked at so far, because it's a very simple class. Also easy to abuse for a lot of things, it's very convenient. And we're gonna do stopwatch.restart. So at the start of our loop, or frame so to speak, we'll just reset the stopwatch and have it start running again, which is actually kind of phrasing it wrong, because there's no active component in here. If you start the stopwatch class, all you're doing is just get the current timestamp and store that. And until you do anything else, the stopwatch is completely dead. It's purely a container for data. It's no active timer or anything like that, so don't worry about that. Which is also why you don't need to dispose it, unlike timer classes. So we do something, and then I'm just gonna sleep, and I'm gonna sleep for frame length, the expected time the frame should last. We subtract the time it actually lasted. So when you make elapsed, it will actually get another timestamp, compare that to the original timestamp when you started the stopwatch, and will give you the difference in this case as a time span. You subtract that from the other time span and sleep for that amount of time. So for the most part, this should actually be the full frame length, more or less, because between this line and this line there will be nanoseconds. It's like nothing. Okay, maybe the console output is involved, so maybe it can actually reach a millisecond or two, but otherwise, yeah. Let's try it again. Should be a bit slower now. That's better. But this is a game. and we need some way to get input in our game. Let's make a new class. This is a new class controller. Let's also make that public. I prefer to make it public. And our controller will have method public. Wait, that reminds me I need an enum as well. Public. I'm just putting that in the same class as controller right now. Public enum input. Let's see, we have no input. Up, down. Right. Okay, autocomplete does some of the work. And this method can now give us an input. Get input. Alright. And we do that by... Let's see. Let's use the standard console. No, key available? Yeah. If no key is available, we just return none. But if a key is available, we do read key with intercept. Yes, please. And now we have to translate this. So that's the key we have. And what we need is a mapping, controller mapping for the inputs. Let's just make it static read only. Let's make a dictionary. Say we make conversion from a character to an input. Mapping like that. New. And we also prefill it right away. So let's see. W is up. A S D. That's left. Down. No, right was right. Okay, that should work. Yeah, okay, we can make this uppercase. It's a static read only. And now we can do mapping.try get value. Console key char. Out input. Input. And the nice part is if there is a match, input will be the mapping as specified in here, and if there is no match, input will be the default value, meaning 0, which is equivalent to none. So we don't have to actually do anything else. We don't have to evaluate the return value of the try. We can just return input directly. Because if none of the keys mapped to our existing mapping, we'll just ignore the input and pretend there is none. So that works. And now our game can actually do something. I'm gonna do... Now let's get a bit interesting. We have the controller here, but that means we need to create a new controller to actually run this. But why should we bother with creating an actual instance of controller if in the end I only have one keyboard? I'm only one single player on one single keyboard. There's only one controller ever. Why don't we make our life a bit easier and just make this entire class static? And that get input as well. And now we can do controller dot get input. Input and then console write line. Yeah, let's just output the input. So let's pretend this is our game. Let's quickly give it a try. None. I'd say that works. So we now have a system for reading our input and have that run a loop for our game. Cool. Only maybe I want to have different mappings. Like, we already have the feature that can translate keyboard inputs. Why not make that actually useful? Okay, let's first Actually, let's put that in the game. Plus, doesn't really merit its own file right now. Public record settings. Settings. And it's gonna have... let's use an immutable. Mutable dictionary. Put mapping. Okay, we're gonna have settings. And these settings can be used for a controller. But that means we can't use static anymore. We definitely need a way to set the mapping up. Well, okay, we can simply create a method for that, right? And statically change this. Well, what if I want to have two different types of controller? Let's say I have one controller for the keyboard. Let's make this a keyboard controller. And I want to have another one that's using the mouse. I'm not gonna bother implementing this right now, but let's just put something in here. Get input, and just input none. Bar. Well, our settings could include another variable, not just the mapping, but also something like use a keyboard. That would work. But that means we do now need to switch between two different types of controller. We can solve the mapping just fine with the static. Just create a new static method and make the mapping internally not read-only anymore. But that would not solve the mouse controller issue. We have two different types of controller. Both have an get input to get as inputs. And depending on my settings, I need this game to use a different one. So either keyboard controller or a mouse controller. I mean, solvable. You can do like that. And put that in an if, right? And all we need now is the settings. If we can somehow pass them onto this run, or maybe store them in the game, we can do use keyboard, the value from our settings, and use that to determine which controller we're currently using. But that's kind of meh. I mean, for starters, we can just implement the internal settings. Let's start with that. Private settings. Yeah, whatever. And actually, we can make it read-only. And let's also make this private only span. Let's also make that a variable, and then we're gonna do public game, which will get settings. Exactly, autocomplete. Thank you very much. Except this part is not right. We are gonna make this easier. Yes. I'm just gonna copy this part out from here. Yes. And so we can use settings.use keyboard. And we can use here rhyme length. Okay, we switched game a bit up. Is for starters, we can now create a new settings object up here. Settings, it's new settings. Let's Okay, let's use an empty for now and true. Okay, and no, not SE, settings, and let's reduce it a bit. Let's set it to 10 frames per second. Alright, so we got a new game. And we use our settings, and internally we now, depending on our settings, use a different controller. This bothers me. It's just everywhere I try to get input, I will now have to include the settings and have to always carry around logic to get the input data. That's just not right in the object-oriented world. That just feels wrong. So, naturally, we take what we learned and we create a parent class. Both keyboard controller and mouse controller are controllers after all. So let's make an abstract class controller. Like that. Which will have public input, public abstract input, get input. Right. And keyboard controller can now inherit from controller. Okay, let's quickly ignore that there's an error, at least for now. And this one as well. And game can now just receive from me a controller. Like that. And down here, I'm just gonna use controller.getInput. Alright. So, as far as game is concerned, we just get a controller. It doesn't care about what type of controller it is. It will get any type of controller which will receive, or from which the game will receive an input. We now have to provide a controller in here, which is fine for now at least, except we can't really choose one or the other because they both don't compile, because they're both, right now at least, static, which means we can't create instances of them. And since they're not instance-based, they also don't have any inheritance here in terms of an instance-based get input. They only have the static get input, which is not the method we're looking for. Static or non-static is a factor that influences the signature of a method. It's not just the return value and the name and the parameters. Static also has an effect, as well as visibility. It all matters for the signature, and we cannot fulfill with this signature this requirement for controller. We have to actually, first of all, make this non-static, and also make this non-static. Also override the keyword, but again, non-static, also non-static, let's override, because we are extending the base class. Now it doesn't compile, now it's not complaining about anything anymore, the compiler works, but now I actually have to bother with creating new controllers, which not terrible, but that also means I can create new keyboard controller, new keyboard controller, new keyboard controller. I can create as many controllers as I want, even though that doesn't really make sense. At least for our current logic, there can only be really one controller. I have one keyboard that has one controller, I have one mouse that has one controller, that's it. So we made it instance-based and non-static, so we can comply with it being inherited. But that means we lose the whole there's only one. For situations like this, where you want to use a class as an instance there's an actual reference you pass around, which usually would involve constructor and just using its type, it's a reference type. But you only want a single instance of that to exist in your whole code, as if it was a static. That's why you use this kind of structure, which is pretty self-explanatory, I think. The controller. Let's call it controller for now. It's a new keyboard controller. So we're just gonna store inside a static field of this class an instance of this class. That means it's going to shorten this a bit, but let's keep it in for now so you can see it fully. We're calling the constructor and storing that in a static field. It's static, so it means this is only created once. This is one instance that exists for the entire class, and it's an instance of the class itself. And the moment this gets interesting is when we specifically implement a constructor but leave it private. This is no longer possible. We can't create a new instance of keyboard controller because the only usable constructor that exists is private, which means the only class that has code that can create new keyboard controllers is keyboard controller itself. Only code that is inside this block is able to call this constructor and create an actual instance. Otherwise, you have no access to keyboard controller. And the only code that's doing that is this static field, which is only initialized once. And that in turn means that this instance is the only instance of a keyboard controller you will ever have. As if this was a static class itself. All you need to do is just go for keyboard controller without the constructor code. And we're just gonna call the field. Oh. Should make it public now, so we can actually use it. Controller. So before I could just use keyboard controller dot get input. Now I could use keyboard controller dot get input. So you think this is the code before when it was static, this is the code now. And for us, more specifically, it's this. This is called a singleton. We have a static, unique instance of a class which cannot be instantiated by anything except itself. So for this class keyboard controller, there will only ever be one instance in your program. Exactly one, no more than that. As if it was static, but it is not itself static class, so you can use all the features still that you get with instance-based classes, like inheriting from a parent class. Or, I mean, you could also do this with an interface, right? Same principle. If I want to implement an interface, I do have to do that in instance-based methods. I can't inherit static fields and static methods and whatnot, or implement them. At least so far you can't. And as a workaround, you just do an singleton, which is the advantage of a static, which means you have access to it from everywhere without creating an instance first. And you have guarantee that there is only one version of it, ever. But the logic internally is still fully instance-based, no statics. So you can make use of all the related features. So I can also go, instead of keyboard controller, I can do the same here with mouse controller. I'm gonna make another public static read only. This time a mouse controller. And then make exactly that, a singleton. We hide the constructor, so the only code that can create a mouse controller is code inside mouse controller itself. And we do that only once for a static field, which means we can do mouse controller, not controller. And what you commonly see for Singletons is that the field name is instance. Yep. Instance, like that. So we use mouse controller.instance or keyboard controller.instance. Which I still could use directly in here if I wanted to. Mouse controller.instance. As if this was static, just honestly a bit longer name for the static class. But I can use it also as just a reference type. Inside a controller, there's stored a controller, which could be a mouse controller or keyboard controller. And because of the way we set them up, we know it's exactly this instance or this instance, not any second instances, third instances we created with a separate constructor call. This might also be an interesting way to start writing your code. When you're not sure if a class should be static or not, then you could try using a singleton, which gives you the advantages of a static, but the code itself is already instance-based, so if you later realize I need to have multiple instances of this that are independent from one another, you can just drop the singleton, make the constructor public, and you get your regular S class. And if you're really sure that your class is no longer needed to be instance-based, and you can make it static, if you really wanted that, well, it's as simple as just making a string replace wherever you used class.instance, you can just replace it with class. And making all your code static itself, of course. But singletons are also a way just to ensure your code can be easily refactored to whatever you need later on, if you're not entirely sure if you're gonna go for static or not, which I'm not sure how often that will happen to you, but maybe this is a compromise between the two. But this actually leaves us now with our original issue. We wanted code that can use any controller here, which worked by giving it an instance of a controller, but that also just moved the logic up here. As far as the logic is concerned, we still needed to settings.use keyboard, then keyboard controller does instance. No, it's just a ternary here and then controller.instance. I still have to add the code in here to specifically choose which type of controller I want based on these settings. And this is right now simple, relatively, but there could be complications involved. One complication might be that, let's go to the controller. We actually don't want a single keyboard controller, we want potentially several keyboard controllers. Because I decided I want to have a local multiplayer for my game. And while I do have potentially two different controllers, one for keyboard, one for mouse, maybe I just want to have two different people on the same keyboard, just using different keys. But that means I have to create two different controllers that have different mappings, and I need to use them at the same time. So the singleton isn't the way to go anymore. We definitely need more than one instance. But at the same time, I don't need a dozen different controllers on the keyboard that all request the same keys. That's redundant. So let's do something interesting. First of all, we're gonna leave the controller constructor private. We don't want anyone to just create a new controller. We want to control, no pun intended, the construction. We're gonna make a method that does it for us, and this method is inside the keyboard controller. and it will give us a keyboard controller with a specific mapping. Now let's say mutable dictionary. This is what we would get from the settings record. Right? Like that. And instead of having this specific dictionary that's static for all the mappings, we're gonna make private read only. Let's just go for a list. Let's make it simple. Keyboard controller. Private. Actually, this is also static. Private static read only cache. Let's simplify this a bit. And, oh, yeah, right. New collection initial. Yeah. Okay, maybe like that. And this method can now take that mapping and check if any of the keyboard controllers in the cache match our mapping. So we're gonna go through the entire cache, for every keyboard controller that's already in there. Let's rephrase this. Yep. Cached keyboard controller. Like that. And now we have to check if that cached keyboard controller has the same mapping as the one we get here in the method. And first we can correct my mistake in this part, because I forgot I needed the mapping still in here. Private. Can actually copy this out. Private read only mapping. Let's make it private field now. And mapping. Let's initialize it from constructor like that. Build private constructor. Dot mapping dot count. If it's not equal to mapping dot count, we continue. We're trying to find one non-cache controller that has exactly the same data, the same mapping. We can't just compare mapping directly, because that's not how that comparison works. We have to make the comparison ourselves. We can cheat a bit. We can try something like mapping.sequence equals, but I think that respects the order, and that order is not necessarily the same in both, even if it's the same content. You can look back in our episode about dictionary if you want to refresh on that. It has to do with hashing, and that can go different ways. Also depends on the order in which things come in, and there's a lot to keep in mind. So we're gonna do this manually. We're gonna go through mapping.reach. We're just gonna look at all the key value pairs in there. We know at this point, because we didn't continue here, both our input mapping and the cache mapping have exactly the same amount of items. So we just have to check if every single key in both mappings overlap, or if every single key that we have in our input mapping also exists in the cache mapping, and if so, if their values are aligned as well. So let's see first. Cache keyboard controller.mapping.try get value for key. Out input cache value. And then can if from that. So first, if it has the key and the cache value equals our input value, then we continue, everything is fine. Otherwise, I have to quickly set this up a bit without making a mistake. Match equals, we start with the assumption that they are equal, and if not, we're gonna make match dot equals false and break, since it doesn't match anymore. And if they match, we can just return cache keyboard controller. that. Okay, a bit of extra code. That's simply comparing two dictionaries, two immutable dictionaries specifically. So the code should work for any kind of dictionary. Not the most elegant way to do this, but it's reliable. As long as I didn't make a mistake. Trigger value and cache value equals... Oh, that looks correct. Okay. And if we end up in the code down here, that means we did not return. That means this is a completely new mapping. In which case we actually do create a new keyboard controller. Using the mapping we provided. Then we just gonna add it to our cache. So for now, we are not gonna worry about anything like concurrency and threading. We're just gonna ignore that completely for today. We're gonna return that keyboard controller. So what we have now is a way from controller to get our carry controller, set again settings.mapping. So it's a bit longer line. We have now a way to create different controllers based on our desired mapping, but the system will still minimize the total amount of instances. So for every possible mapping we can do, there will only be one instance of a keyboard controller. Still have to fix this, use the internal variable now. And this type of handling instance creation, this more controlled creation for multiple instances, we could call this a factory method. A very primitive, simple factory method. Factory in the sense that we're not creating the keyboard controller ourselves, we're instructing someone else to create it for us, to build something for us. A factory, and this is a factory method. Very simple one that's included in the class itself. And we need that because if we only add the code in here, well, that means the instance was already created. As soon as someone calls the constructor, the memory is already reserved and we can only change the values in that reserved memory. We cannot return anything or do anything in here that would tell the caller, don't reserve new memory, reuse existing memory that matches your requirements. So we have to do that using a different method. And since this different method is not bound to a specific instance, we have to make it static. So we have the keyboard controller itself, which is instance-based still. But to create them, we have to call a static method that will create that for us. Let's minimize the code a bit, get an overview. So we have static cache of existing keyboard controllers. And we have a method that will either read something from this cache or create a new controller, adds it to the cache and give us that. So whenever we call get or create controller, it will guarantee we get a keyboard controller. Either one from the cache or a fresh one and created because none of the existing ones matched our mapping. The constructor is private, so the only way we can create new keyboard controllers is through this method. Meaning we can guarantee, because we wrote the code ourselves, that each keyboard controller is unique in its mapping. No keyboard controllers will ever have the same mapping because then there would be the same instance we return from this method. That's still limiting the instances we create, but we can have multiple different instances, which is different from a singleton, which could be only exactly one single unique instance throughout the entire runtime. In theory, we could also expand this code to at some point invalidate values in this cache. Decide we don't need this anymore, it's just wasting space, just clear out cache inventory, basically, that's not used. But that makes things a bit more complicated because now we have to decide when do you delete stuff from the cache. When is it worth it to throw it away rather than waiting a bit longer to maybe reuse it after all. Different topic. Now this is a factory method. And we could do the same for the mouse controller. Though for the mouse, it's unlikely that we get more than one. So for the mouse controller, at least for now, a singleton still makes sense. We have a factory method for the keyboard controller, because we have a cache of multiple different instances, but a singleton for the mouse controller, because we're only ever gonna need one single instance, a unique one. Except I don't like that I have to write this code out. It bothers me. I mean, it's just one part in our code, right? We're setting everything up and it's just this one line in our code where we're gonna need it, right? Right? Well, considering that we already talked about implementing the factory method so we can allow for multiple instances at the same time, because I wanted to have local multiplayer, well, it only makes sense that we're gonna have multiple different controllers, which all might be created in different ways. Right now I'm only using keyboard and mouse. Maybe I'm adding a gamepad. Maybe I'm adding a webcam, like Connect Cam or something, but 3D. Maybe foot controllers. Maybe a DDR mouthpad, footpad? Pad? Banana? Like there are all kinds of controllers out there, possibly. Right now I only use 2. I could add a million different types that all have their own unique way of giving me input. And they're all just controllers. And I don't want to remember the code necessary to decide which one to call and to remember how to get an instance, because for keyboard controller that worked through the factor method. Mouse controller was a singleton. Maybe the gamepad controller will be just a standard constructor call. I don't know. It could be actually a very complicated process to create an instance of controller. So even if I'm only calling that in one part of my code, that is for now. I might need to call this several times. And once I add more controllers, this code will get more complicated and have to remember to change it everywhere. Of course, that's not what we're gonna do. Instead, we're gonna use the abstract class and move a factory method in here, just like our getController here, that can handle all controllers. Public static. Now this is interesting. Controller. It works. And since we know it's depending on the settings, we're gonna provide the settings as well. And now we can just go if settings.use keyboard, then return keyboard controller dot get or create controller with settings.mapping. And otherwise, we're just gonna return mouse controller.instance. And if we add any other types of controllers, we just add the code once in here, including all the necessary steps to create it. Like, could imagine we have another enum maybe for different types of controllers, and we just add a switch in here that goes through all the different types, depending on what we provide in the settings, or whatever else we're gonna use to decide which controller to create. And our program just goes, well, please, Mr. Controller main class, give me a controller. I don't care what it is, how it works, I just need it. I just need something that is a controller. And we offset that to a factory method again. This too is a factory method. Just this time it's not in the class itself, like with keyboard controller. It's in a different class, the parent class right now. And it's not just for one type of type, it's actually creating different types depending on your input. So the keyboard controller factory method created always a keyboard controller. The difference was just in the specific instance we get, how it's set up, like the data stored in that controller. But this factory method creates not just different versions of the same type, it also creates different types of controllers. And it's all abstracted away behind just the base class, which is abstract controller. So this is a slightly more abstract factory method. Less simple, because it involves several types now, and because itself has to contend with different logics for these different types. But it successfully uses all these different logics. They're all centralized in this one place where everything is determined in terms of your business logic. And I can just use it. With a peace of mind, it will just work. Let's just give it a try, what's going on right now. So right now, nothing works, which makes sense. I didn't provide a good mapping. Let's just quickly make a mapping. Dictionary. No, let's do it the right way. Mutable dictionary, crate builder. And builder.add W WASD right, down, left. Looks good. And wait, why is it not? Please. Okay. Dot to mutable. Let's see. It's no. Okay, that's fine. To mutable. All right. Let's try again. Nah. Now it works. Okay. So that worked. And let's switch to mouse controller, which will always return none, so it's not expected to do anything, but the code is working. And okay, another simplification, of course, I didn't catch the issue of more time elapsed than a single frame, in which case we wait negative amounts of time, which sadly doesn't work. C# doesn't contain time travel yet. Maybe in C# 5000. So let's see, we added the settings. Do we actually need the settings still? Let's keep it in there for now. We might need them later. Oh no, you know what, let's clean up. Let's clean up. We don't need the settings anymore in here. Let's remove it. Remove what we don't need. So it means we can drop it in here. Right, so that looks quite good. Let's do something interesting with controller. Just to demonstrate something. Public class dummy. And we're gonna have from controller. I demonstrated something like this a while back with interfaces. Gonna do the same with the mouse controller. And we could bother with a Singleton or something in here, but we don't really need it, because we're gonna do the Singleton kind of in the base class. Public static read only, controller, dummy controller, new dummy. So this is a public class, we could create it everywhere. Let's switch this now to private. The code will still work. The controller itself holds the reference and calls the constructor, which it can, because it's a private class, but it's defined inside the boundaries of our controller. And it fulfills the criteria for a controller, so we can return it as a controller. So now dummy exists as a controller I could actually pass on. So I could in here go for controller, or dummy controller. This is still in the style of a Singleton, but it's no longer stored in the class itself. Just like this factory method was used in keyboard controller, and this factory method was used outside of the keyboard controller. This time we had the Singleton basically inside a different class than itself. The only reason this can effectively work is because it's a nested class. Otherwise, controller would need to have access to the constructor, and that means if controller gets access, other classes will also be able to get access. This way it's still contained all in here, so we can still fulfill the requirements for Singleton. Just slightly different. And it means we have kind of a dummy controller we can input whenever we don't have a defined controller. We don't want to use null, we use a dummy controller. If no controls are defined, it's a dummy controller that never gives any input, but our code doesn't care because it's still receiving any input, even if that input is none. So that's good. But that shows us something interesting. Besides the Singleton logic outside of the class itself, it demonstrates that controllers don't always have to make sense. These are controllers, they make sense. That's an actual controller we use during normal runtime. Mouse controller as well. Even though I didn't implement it properly, a mouse controller makes sense during our runtime. The game actually uses multiple controllers. Maybe gamepads, keyboards, mouse, anything. But they are actively used for normal, expected use of the program. The dummy controller is not expected to be used for a normal run. It's used as a standard, as a default, just to make sure that the program doesn't break. Just use it until something else fills the void that is the dummy controller. There could be other weird controllers that don't expect to be used normally, but that have specific functions for you while designing the program, or in niche cases while it's running. For example, what if we have, why not make one? Why not, let's just make one. Public class, record controller. Controller. And yeah, let's implement it quickly. And this thing might private read-only mutable array input. Oh, that's fine. Private read-only mutable array input. Inputs. Yeah, like that. And we're also gonna add private int index. What the hell? Next, that's good. Index equals 0. And I'm gonna do if index, well, let's do this. Inputs length -1. Then if plus plus index greater or equal to inputs. Can't actually now. Let's. I'm trying to be fancy right now. Not sure why. Index equals. Not quite that. Length is good, but index +1 modulo. Yeah. Let's do it branchless. Let's be fancy. And then inputs index. All right. So record controller, if you can figure out what this does, gets a series of inputs and just replays them in order. Every time we go get input, it just uses the next input in our input list. And once we went through all the inputs, we just start at the beginning. Now, instead of record controller, maybe macro controller makes more sense to you. So I'm imagining something like replay of a game. You just, while someone's playing, you record all the inputs, and then you can replay the entire game by just replaying the inputs again. This is not necessarily expected for normal use. Where I do see this very useful, however, is for you during development for testing. Remember when we talked about automated tests? Imagine you want to test a certain feature in your code, in your program, and for that you need to have the game start normally and receive a series of inputs that recreate a certain behavior that you try to fix? Well, you could of course make that all manual and input the inputs yourself, but you might make mistakes. Maybe that needs to be very precise to get a very specific situation. And of course, you usually want this automated because you don't always have time to go through all your tests and do that manually. If the computer can do that in a few seconds for thousands of different test cases, why not let it do that? Instead of you wasting hours of your day for maybe a handful of test cases and completely forgo any other work. So you have a special type of controller that you use for development that can recreate certain inputs. Or you use a dummy controller because you don't really care about the inputs at some point for your tests. You just care about the program not crashing, and you're testing something else that is entirely independent from player input. You just want to see the game start and wait for a few seconds maybe to test performance. In that case, a dummy controller is perfectly fine. So in these special cases, you might want to have a special controller, like the dummy, which doesn't do anything, or a microcontroller, which has a very specific behavior. In other cases, you want a normal controller, so to speak, which is just getting input from a keyboard or the mouse and passes that on. What we have now is two different groups of controllers. We have 4 different controllers so far, and they're all independent. So we have 4 different controllers specifically, but we can group them up into normal controllers and special controllers. That means we have already 2 different groups. And just like we can create a factory method that can create different controllers for us, we can also create a factory method that creates a factory method for us, so to speak. Well, usually you don't create a factory method itself, which you could do with delegates, but you create a different class, a different factory. Let's do that in here. Public class controller. Great. Let's call it factory. Let's call it what it is. Controller factory. And this controller factory, public, is also abstract. And it has public. Yeah, let's do it like this. Public abstract. So we're mashing up a few things together, but for now, let's just say it has a method called abstract controller, create controller. Let's call it like that. And we have 2 specific implementations, public class, normal controller, I can type factory, which is a controller factory. Gonna do that in a minute, and then we're gonna add a second one, which is special controller factory. They both inherit from controller factory, so they both have a create controller method. And we're gonna move this code into the normal one. So normal controller factory creates a new controller. We should probably also let's make it simple. Let's add the settings in the arguments. Let's keep it simple. Let's not bother with any stored data. So we moved the factory method into its actual factory. So we completely removed it from the controller family. You can drop it in here. And instead, we're gonna do that through a controller factory, a separate class entirely that still does the same logic, still calls the different controllers, but only for its normal controllers. And for the special controllers, let's use the same logic, only this time it's in different contexts. When we want to use the keyboard, what we actually want is a new microcontroller. Let's say empty for now. Not sure what I'm going for with here, and otherwise return dummy controller. So the logic itself doesn't really matter. It's more that we have a factory that's specifically for creating regular controllers and another factory entirely that creates special controllers. But they both have the same signature because they both inherit that from their base class, which again could also be just an interface, which is more common. So just to get this through your head one more time, we have different controllers, which all inherit from controller. Let's actually make a new class. Let's put these out and in here. Like makes more sense maybe. Controller. Let's rename this controllers. No. Okay, so we have different controllers. We have the keyboard controller, which reads keyboard input. We have mouse controller, which reads mouse input. We have a macro controller, which is specific in that it just plays a pre-recorded set of inputs. And we have a dummy controller, which does nothing, but it's still a valid controller. And these controllers have to be created in different ways. Like mouse controller is a singleton, keyboard controller has a factory method, macro controller is an instance, just regular constructor call, and the dummy controller is another singleton. And to create these, we now have different factories. We have normal controller factory, which can, through its method call, give you either a keyboard or a mouse controller. And we have the special controller factory, which can give you either a macro controller or a dummy controller. Again, the specifics for the logic doesn't matter here. It's just, it creates different controllers than the normal controller factory. But they both are controller factories. They still inherit from the same class. So they both have this one method I can call. So up here, I can just take a controller factory. Let's not worry about how we get that for now. Just if we have a controller factory, we can .controller factory.create controller settings. We can do that. Complaining right now because we have not initialized that yet. But for that, we now add another factory method in the factory, which is public static controller factory create factory. And we're just going to use a simple Boolean. Well, let's call it special. Default is false then. Have special and return new special controller factory, and otherwise return new normal controller factory. So what we do in here is we're going to call controller factory, the create factory, and we can decide, do we want the special one or do we want normal one? And this decides which factory we get. And these factories themselves now get our settings, which split the decision even further into which specific controller in that group. So if you imagine like a tree, a decision tree, at the very top, at this point, when we just get the settings, everything is open. The controller the game uses could be anything right now. We make the first decision. What general type of controller do we want? A special controller that's used for us for debugging or anything? or a regular controller for normal gameplay because a user just started the program, which is more common. And we decide that by choosing a different factory. They're all controller factories. They will all give us controllers. It's just they will give us different controllers. Depending what factory you contract, they will give you different things. They could look similar, they could be very different. All depends on what factory you contract. We choose, based on this boolean, we get any type of factory, and these controller factories themselves can now make a separate decision within their specific group that they deal with. They will now create an actual controller, like a real controller, not just a factory, but an actual controller based on some input settings. And this controller will then be passed onto the game. So we start from all options, 4 different controllers, to one of the 2 groups. So there are only 2 different types of controllers left open, and create controller will then make the decision which of the 2 will pick. We create a factory, and that factory creates a controller. The logic is actually very simple, but it's a bit mind-bending if you're used to I create an instance of my class. That's all I need. And technically we can do this a bit more extreme. We can actually put a layer of abstraction on top of that. Right now we have a factory method that creates a factory, which itself has another factory method that creates a controller. We can actually have a factory that creates factories, that creates factories, that creates factories, that creates factories. You can have an endless row of layers upon layers upon layers of factories that create more factories, that create more specific factories. Of course, that's kind of overkill, but it could happen, though it's of course rarer. Usually you have just choose a specific factory and that factory creates something for you. So these 2 layers of abstraction are quite common. Like a single factory method, very common. Having a factory, still very useful. Having a factory for creating factories, things get a bit silly slowly. So usefulness is debatable at that point. If I see 3 different layers of creating factories, I'm wondering what the hell the programmer did. Like, why? There must have been an easier way. Anyway, this is factory methods. This is factories using factory methods to create factories, to offer factory methods to create controllers. A bit mind-bendy, but actually very simple. It just, you really have to, once it makes this click, it's simple. But this click is, okay, I shouldn't say it's simple if you need this click, because the click is always the difficult part, right? Anyway. Let's get away from singletons and factories and deal with our last topic for today. I have to do all of this to create a game, which is actually not that much. It's very little I have to do, especially this top part here. We can ignore that. This is what we actually need to create the game. Not much, but there could be more involved in this. Could be a lot more. Maybe beside the controller, we also need to decide visuals. Which output do we use? What output system? Do we have any networking? How do we make the connection happen there? What kind of UI do we use? Sound engines? But there are a lot of things we have to consider when creating a complex object, maybe. And to slowly get all the variables together and set everything up correctly and all of that to just create a single instance of the game that can run. That can be difficult to manage at some point. You forget how to track everything and what the rules are and in which order you have to create what. And you have to keep all of that in mind whenever you create a game. And if you have a large team especially, you might have people that are specialized in setting everything up, that know exactly how to handle these factories, and others that know exactly how to use the game internally and use the controllers behind the factories. So you have to make it simple for one team to work with your data. You provide them a special tool. And I'm just gonna add this to the same file as game, because this is gonna be special class we're gonna call game builder. You already seen this type of class. You've seen it today, actually. I used it in here. This is the builder. It's a special type we use exclusively to create another type. It's just helpful for us because it allows us to do things we can't do with the class itself. Like an immutable dictionary, we wouldn't be able to fill it directly because it's immutable. We can use a tool to build up a dictionary that is then converted to immutable. So this right now is a tool because we can't do it any other way. But builders can also be used to simplify the process. So we're gonna make public constructor just to make clear that we do have one right now. So I specifically don't have it private. So I'm leaving this here. We don't actually need it otherwise. And this game builder will keep track of a bunch of things. First, it's just gonna keep track of settings. And it's gonna keep track. What do we else need for the game? What did I say? What else do we need for the game? We need the frame rate. Frame rate, is it? Wait, was frame rate? Yeah, it's fine. Frame rate. Setting frame rate. What else do we need? We need to cite private pool special controller. Let's keep that in here as well. Special controller. And it can use all these different settings, all these variables we have when creating a new game instance. And it's giving us an easy way to manipulate that. First, let's some default settings to start with, which is going to be empty and true, I guess. True for that. Frame rate, gonna set it to 60. And special controller, let's start with false. So the default setting would be... Actually, let's use special. Let's use this combination. So basically we use the dummy controller by default. So this is the default we start with. And now we're gonna add a method, void mapping. It's gonna get immutable dictionary, char, input, lowercase, mapping. And we're now gonna change the settings, and because settings is a record, we can do that with the keyword with, which changes only one part of it, with mapping equals mapping. It's all immutable dictionaries, so we can just directly assign it and don't worry about any side effects, which is quite convenient. And let's make another one. Public void frame rate and FPS. And we're gonna set frame rate to FPS. That. And for the keyboard input, let's do another two. Public void use keyboard. This one doesn't get any variables. I'm gonna use a different style for method. We're just gonna make it so that by default, when we call this method, we forcefully set this to true and width, and then use keyboard equals true. And we're gonna make a copy of that. Use mouse. And we're gonna forcefully set it to false. And we're gonna do something similar now for the controller. Void special controller. It would help if I can type correctly. Special controller, like that. Special controller equals true. And normal controller we set it to false. All right. So my program, instead of doing all of this, let's just put it down here. we're gonna start with game builder. So we create a new game builder. And this game builder can now give it a mapping. Give it builder to immutable, so for example. And game builder dot frame rate, that's gonna set it to 10 again, so we can see it slower. Game builder dot, let's use the keyboard, and game builder dot normal controller. Right, so this game builder instance now contains all the different settings we want. Now we just have to instruct it to do all of this and put together a game instance. And that's going to be the big method here. Public game build. Let's call it build. And now we can start by creating the factory. Actually, let's just copy the code because I am lazy indeed. A factory, depending on special controller. And then here we can just use the settings. And for that, we're gonna use frame rate. And yeah, we don't do any caching, we don't do anything with it. We can just directly return it. So that means we can also drop all of that in here. Just use gamebuilder.build and have our game. So I set up my mapping for the keyboard inputs, and then I created a new game builder, which I use to slowly set all the different things I want. And then I can just have it build a game. And I don't really have to think about how to operate things like the controller factories, which can be a bit confusing if you're not aware of the different factories and their different control outputs. You would have to use the documentation to figure that out, but the game builder makes it simple for us. We just tell it directly, I want to use a keyboard, I want to use a normal controller. Okay. Don't have to worry about what the controller factory is, really. Just have to tell it what I want to use. And to make this a bit more comfortable to work with, we can do something special. These methods can return something. And what we're returning is this. We have to, of course, change the type. But that means this method mapping, we call it on a game builder instance, any instance, and it will return the same instance again, which by itself is pretty useless. But let's just quickly go through here. That's a special one. Just gonna refactor everything quickly. Let's choose it from void. I mean, you could just use search replace, but this is fast enough. They all return the same instance again, and so this can be changed. Let's put it back to game builder, the full explanation, and then remove the semicolon, because we can do this. We can do dot mapping on the instance we just created, and then on that we can call this again, and then call this again. Of course, moving them to new lines is a bit more easy to read, but this is how we create the builder and set it up. It's a bit easier to read. We create a new game builder, change the mapping, the frame rate, the keyboard selection. We want normal controller. This is quite common for the builders. So you can write it out like here, a bit more in depth, but you can also make it simple and chain it together. And actually we can do all of this in one go if we really wanted to. Like that, and put the build in the back. So this is a builder, a different way to create instances without really worrying about it. And now we are almost finished. There's only one last specific pattern for creating new instances of data that we should talk about. But we don't actually need to talk about it because you already know it. We've talked about it, you've seen how to implement that. I've made explicit implementations and we used a version of that already today. And it's this right here. What we did here is if you ignore for a moment how records work, we created a full copy of settings, but in that copy changed this one value. And that gave us a new instance. So I can take settings, an existing instance of something, an existing object. No, not that. And I can create a copy that has a few changes and have a new instance. So this settings instance here is different from this instance. They are separate parts in memory now. But they are mostly identical, except for use keyboard, which is potentially different. I mean, depends on what we had before, but I changed this one value, but otherwise it's a full clone of the original settings. And that's the keyword. We talked about a copy constructor before. I used one. And I briefly showed you the iClonable. What's iClonable? iClonable interface with the clone method. That is prototype. You basically create one instance of a class. That is your prototype. That's basically a full featured class with all the different settings you want. It's like creating a full copy of a game with all the different settings we have, the controller, the frames, whatever. And then just taking all the data, changing only the parts you actually want different, and have a new instance. We duplicate the existing instance 1 to 1 and change only specific parts. This is our prototype, this is how we want the game to work. And then we change maybe the frame rate. We want a full copy, exactly the same game with just a different frame rate. We take one prototype, we make a copy constructor which will copy everything, deep clone 1 to 1, and change one thing. So the thing we naturally do with the with keyword and records. The thing you have already used a couple of times, hopefully by now. That's prototyping, that's the last of the, I'd say 4 different ways to, actually, let's say 5 different ways you can create new instances. The one you already knew from the very start is just constructor call. The most basic, simplest way to create an instance. You directly call the constructor, which is what's always in the end needed to create an actual instance. Sorry. We have the prototyping. You have prototypes which are just full instance that you can copy one by one. And the thing that sets us apart from just calling the constructor directly is that you don't have to provide all the values for that specific instance yourself. You can just take the prototype that's configured in this specific way and make small changes to that. That's prototyping. We have singletons, in which you don't want any instance creation at all, except for maybe one. You want to have instances that behave like static, by storing a static field that has the single instance that will exist throughout the entire lifetime of your program. Can be also useful. Instance, but only one through a single constructor call, never again. You can have factory methods, which are just a way to keep more control over the process of creating new instances. Especially useful for a case like this, where you might not want to create a new instance. So, for example, you want to reuse an existing instance in former cache. Could also be that you don't want the compiler to waste resources on reserving memory only to then throw an exception, which is also maybe an option. You want a factory method because there's very likely an error in the input, and you want to immediately throw an exception and return, and you don't want the compiler to waste time on reserving the memory space for the constructor call, only to then, after it's reserved, tell it to throw it all away. Unusual, but possible. And factory methods themselves can be easy, like in this case, where it's just a static methods in itself, in its own class. Or you can make it more complicated by having factories that can create instances. The factory pattern, factory methods, and factories itself. Factory methods, factory classes, factories. The most complex way to create new instances. And last but not least, the builder, which is a bit like prototyping, in that the builder will have a default setting internally, but that doesn't necessarily mean you can create something with it. So it's not a given that I can call a builder and directly build. I'm used to that, that's usually the case, but there might be things you are forced to add. Though in that case, usually you would actually have mandatory values, arguments in the constructor for your builder, for the required data, and only the optional stuff that doesn't need specific settings is provided through these chainable methods that can slowly build up a set of data that is then compiled into a single instance with the single function call build right now, or whatever else your class is gonna use. So, constructor call, singletons, prototypes, builders, and factories. 5 different ways to create and manage instances of your classes, which all have their own unique uses and advantages and disadvantages. And that's all for today. I don't have any homework. I'm not sure if I'm ever gonna have more homework from this point on, because it's pretty hard to judge the homework from now on without extensively reading your code. So a single here's a quick solution is probably not gonna cut it anymore, because there are so many different ways you can solve this stuff in the future. So, lucky you, no more homework? Probably. Expect that as a default. Right, then that's all for today. Till next time.